Mahajan. Yesterday we discussed the probability and their concept. What is the probability? What is the application of probabilities? When will you will using the probability concept? Some example also discussed how to consider. There are in previous lecture we are discussing about three main examples: coin example, dice example, and card examples. Right? Today all these things depend on the probability. What is m, what is n, p equal to m upon n is a total favorable condition and m is according to condition, right? Today we are discussing probability distribution. Probability distribution, according to them, we are understanding distribution, it means how to distribute the probability in your problems. The outline of my lecture is random variable and its types, probability distribution, discrete probability distribution, and continuous probability distribution. So today we are discussing these 4 points. Now, what is random variable? Random variable, outcomes of an experiment expressed numerically. It means, for example, how to represent it numerically: x equals to 0 and 1. 0 and 1, the possible values, and x represent here random variable, and random event is what? 0 or 1. Now we are taking one example here. Pick up a card, assign 0 if it's not hearts, and if 1 if hearts. Do this experiment 5 times. In previous example, in previous lecture, how to represent, you know that. Now here we are calculating the random variable. So suppose your card is, pick up a card, assign 0 if not hearts and 1 if your card is heart. So the combinations are heart, club, spade, and diamond. So for heart we are representing 1 and others are 0, 0, 0. So my random variable is 1, 0, 0, 0, 0. In the case of toss a die twice. Count the number of times the number 4 appears. Right? So 0, 1 or 2 times. So 5 and 4. So this is the 1 combination because we are appears, meaning is mentioned here. In the case of flipping a coin 100 times and recording number of H and T as say 1 and 0. So the H, T, T, H, H, T, T. So H, because our object is H, so 1, 0, 0. Here again H, H, so 1, 1, 0 and so on. So this is the random variable represent. Now we are discussing about discrete and continuous random variable. So what is a discrete variable and what is a continuous random variable? So a discrete random variable has a countable number of possible values, has discrete jumps or gaps between successive values. Third, has measured probability associated with individual values. And fourth, it is a result of counting something. For example, the number of children in a family, the number of students in a statistics class, the number of students in mathematics class, and so on. So it is a countable. Now a continuous random variable has an uncountably infinite number of possible values. Number 2, moves continuously from value to value. The third, has no measurable probability associated with each other. Yeah, each value, sorry, not each other, each value. Fourth, it's a result of some time of measurement. Now example is height of students, speed a car, duration of the math session, pressure in an automobile tire. It means it's very clear. In the discrete you are countable easily, that is finite, and here your speed of car, sometimes your speed of car is 40, sometimes is 45. So your speed lie between 40 to 50 or 50 to 60. So this types of example is called continuous random variable. Now, the third main point is a gating probability distribution. How to gate? So, suppose you throw a 6-face dice. All of you know that in a dice there are 6 faces. 1, 2, 3, 4, 5, 6. So, the sample space will be 1, 2, 3, 4, 5, 6. And you want to see 4 coming up. My object is to see 4 coming up. So here we represent S equals to the event that 4 occurs, and F, that is the event that 4 does not occur. It means 1, 2, 3, 5, 6. Here 4 is not included. In other words, we will say that S is a success and F is a failure. Success because my object is 4, you are occurring, and failure, it means not involved 4 in this series. So what is the success? Because the total number of favorable condition is 6, because in a die 6 are, you know that, yeah, the picture shows that 6 are faces here. So n, m upon n is 6, and m, because only we want to 4, the 1 by 6. But in the failure cases, pf equal to 1 by 6 plus 1 by 6, because 1, 2, 3, 5, 6. So 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So total equal to 5 by 6. All of you clear here? Now the x, that is main thing, x random variable which takes value 4 or other, right? Let's say the random variable takes value as 1 when event S occur and takes value 0 when event F occur. It means suppose you got 4, so you can mention here 1, otherwise you can write here 0. So in the case of random variable x, so there are two random variables, 0 and 1. So for 0 case, the probability P equal to 5 by 6, we are calculating in above, and 1 by 6. Next is try it. You can try it. Can you get the random variable and its probability distribution of 12 phase dice? My dice is 12 phase. Let's say getting 4 or less is event of interested. Now all of you know that sample space, total phases you are considering here, it means 1, 2, 3, 4, 5, 6, 7, 8 and so on up to 12. What is my object? I want here again 4. So success is 4. So S equal to the event that 4 or less occur. Less occur because the object is less occur. I also mentioned the question. So less occur, it means 1, 2 and 3. We are not considering 0 because 0 is not mentioned in the phase, cubic phase. And F, the event that 4 or less does not occur. So how many numbers? 5, 6, 7, 8, 9, 10, 11, 12. So my random variable again same 0 and 1. In the case of 0, it means you are identify 4. So my phase of the 8 by 12. Okay. And for 1, 4 by 12. So this is the finding sample space. Now I given one problem again here. Same got a slot machine for his small casino. You need to pay $2 per play. There are 4 possibilities of outcome: jackpot, all fruits 3 in row, at least 2 same signs, fruits slash dollar, else you lose. Here's the probability distributions are: x equal to -2, 15, 30 and 85. And px probability is 0.977, 0.008, 0.006, 0.001. What is the average or expected play gain or loss on one game? So expected gain, how to calculate? You know that my x is -2, my 15, 30 and 85, and their probability also given in the question. So you can multiply and calculate the how many dollars you can identify. Yeah, you can calculate. Now the second problem I am considering here, the following table contains the probability distribution for the number of traffic accident daily in small city. I mentioned according to question how to accident done. So the number of accident daily. So what is the x? 0, 1, 2, 3, 4, 5. Okay, and their probabilities are also given here: 0.1, 0.2, 0.45, 0.15, 0.05 and 0.05 again. Now my question is, what are the average number of accidents per day? And my second question is, what is the standard deviation? Now we are defined here the formula of expectation, expected value. The mean of probability distribution is also referred to as its expected value. Here expected value represented by Ex. Ex equals to mu x, also you can represent by mu x, equal to summation of I varying from 1 to n, because my value is finite, so I can consider 1 to n. Xi px equals to xi, where xi is the value of the random variable for outcome I. and mu x equals to is the mean of random variable x, and probability of x equal to xi is the probability that the random variable will be outcome. Now, how to calculate the variance and standard deviation? So, variance of x is equal to rho square. Because we are calculating the expected value, so you can also modify the formula summation of I 1 to n xi minus ex whole square into px equals to xi. So standard deviation, you know that, under root of variance. Now here again same, xi is the value of random variable for outcome I, and pxi is the probability that the random variable will be outcome I. And what is ex? Ex is the expected value of the discrete random variable x. And standard deviation and variance, you know that rho square is the variance of discrete random variable, and SD standard deviation of the discrete variance random variable x. Solving the, I am giving here the problems solving the road accident problem, because I already mentioned the road accident problem here. So I calculate according to formula. All x is given, probability value is given. You can multiply xp, x minus ex, xi, ex ka whole square, and then you can multiply by pxi. So ex, the average number of accident per day, equals to 2, and the rho, that is standard deviation, equals to 1.183 to 1597. Now here I again take second example, x down 5. You can solve this, economic conditions are given, you can calculate the values. My question in this question, but what is the relation between the two investment, because here investment data is given, so you calculate and find the values. Now my next part is a covariance. The covariance measure the strength of the relationship between two numeric random variable x and y. So covariance of x also represent rho xy equal to summation of I varying from 1 to n xi minus eix in the bracket, first bracket, into second bracket, yi minus ei bracket complete pxi yi, where capital X represent here discrete random variable x, xi equal to the ith outcome of the discrete random variable, y equal to discrete random variable y, and xi equal to the ith outcome of the discrete random variable, and pxiyi equals to probability of occurrence of the ith outcome of x and ith outcome of y. Here I varying from 1 to a finite n. It means covariance, a positive covariance indicate the positive relationship, and negative value, it means negative covariance indicate negative relationship. And suppose your covariance is 0, indicates that the two variables are independent. So the two investment, according to calculation of covariance, is investment equal to minus 19,275. It means indicate the negative relationship, which means the two investment are varying in the opposite direction. So you conclude that when the return on the investment is high, typically the return on the other is low. Now how the mathematical model for probability distribution. So probability distribution is a mathematical model describes the probability of observing various values of a random variable. The formula of this equals to fx equal to 1 upon standard deviation into under root 2 pi whole into e to the power minus 1 by 2 in mod x minus mu upon standard deviation the whole square. Here mu represent mean. Now the diagram, according to diagram, it is very clear. So the upper red line going to say that this is the mid mode median, and the probability distribution distributing first part is a discrete and second part is a continuous. Again discrete is divided in binomial, Poissons and hypergeometric, and continuous series is defined as uniform, normal and exponential. So now we are summarize what today we are teaching here. So what you are understanding here. So the first, a discrete random variable, and second is a continuous random variable. So what is a discrete random variable? Counts occurrence has a countable number of possible values, has discrete jumps between successive values, has measurable probability associated with individual values, probability is high. So according to example, according to diagram, that is a discrete random variable, and in the continuous random variable measures, example, height, weight, speed, value, duration, has a uncountable infinite number of possible values. Second, moves continuously from value to value, has no measurable probability associated with individual value probabilities area. Now, I think all of you understanding my second chapter. Now, the next chapter we will discuss after some time. Thank you.